Is my screen visible?
Yes, sir.
Okay, Shivam. Shivam, so 1 minute. Good evening, everyone. Welcome to the live session on design of steel structures. My name is Saurav Kumar Singh and I am doing PhD from Department of Civil Engineering, IIT Kharagpur. So, uh, Shivam, you have asked out about eccentric connections. Means when bolted joint is lying perpendicular. Means when load is lying perpendicular to the plane of bolted joint. Okay. So, are you able to see your query on discussion forum?
Yes, sir.
So to maintain the equilibrium condition, the tension above neutral axis should be equal to compression below neutral axis. Since these are two forces, not the stresses, and you have attached one figure also here. So, Shivam, do you recall from strength of materials class that when we are analyzing a beam, means cantilever beam or simply supported beam, then we draw the stress distribution, means above the neutral axis and below the neutral axis. So that diagram which we used to draw is of stress diagram, and force, whatever tensile force or whatever compression will come into picture, is always acting through its centroid, isn't so? Means here you have shown here centroid of yes,
Excuse me, although this question has already been answered by Anindrup Lahiri sir in
okay,
the
okay,
previous
okay,
session.
okay. So, can you tell me that you have also posted one more query over here? So, uh, let me see. This second query, AV and AVG. So, is
Yes,
this?
sir. This was also being addressed in the previous live session by
Okay.
Mr. Anandrup Lahiri.
Okay. Actually, I didn't went through his live session last week because I was having my seminar this week, so that is why I was not available. So that is why I today itself I went through the discussion forum. So I was not knowing this thing. So let us start from previous year's assignment question. So half of the assignment part today I will discuss, and half of the assignment will be discussed by Mr. Anand Roop Lahiri. Okay. So I will request you to please open your copy and pen, and please have with your calculator so that you can solve the numerical problems. So here in question number 1, it is saying that when a lug angle is attached to the main angle, it should be capable of developing a strength of not less than blank space in excess of the force in the outstanding leg of the main angle. And here options are given. So uh, can you tell
It
me
is
that first of
40%.
all why we use lug angle? What is the use of lug angle from the lectures?
Lug angles are provided when the length of the connection is too big and it is uneconomical when the load is high. So that's why the outstanding leg of the angle section is connected with the lug angle so that efficiency of the connection is increased and the lug angle is connected to the gusset plate.
Okay, and one more reason. Do you recall?
Uh, One more reason. It is one is the connection. Other is um, the
Uneven, I will give you hint. Uneven distribution of stresses will be there in main angle.
yes sir uneven yes sir the outstanding leg and the connected leg will have equal means proper distribution of the load will be there. Mean the ratio will be yes sir.
What that
The
effect we call?
uh, means the ratio of the gross angle of the connected leg and the outstanding leg, it will be in that proportion.
Yes, you are in correct direction, but I'm trying to ask that there is problem na means there is one effect something called so that
Shear
effect I
lag effect.
yes, yes, fantastic. So these are the two main reasons. First is of in order to reduce the length of the gusset means connection length we are reducing, and other is shear lag effect. So fantastic. So please tell me what will be its option, means which option is correct?
Option D, 40%.
Okay. Yes, so option D, 40% is correct one. Now coming to the next question. uh, you can do one thing, as this is a numerical problem, so you need to calculate the values. So for that you can take a snap of this screen, or you can also means do one thing that this screen is open in front of all of you, so you can take the data, write down the data from here, and you can start solving the problem. So question 2 is saying calculate the number of M18 grade 4.6 volts required for the connection of the member OC. So this is member OC. So this is talking about this member as shown in below in the figure. Thickness of gusset plate is equal to 14 mm. So thickness of gusset plate is reported here 14 mm. Assume pitch and end distance. First of all, it is written here first pitch 50 mm and then end distance 35 mm respectively. Consider Fe 410 grade of steel. So here you can see that a member OC is subjected to a tensile loading of 170 kilonewton, and the section size is given here ISA 90 cross 60 cross 8. The dimensions are in mm. So here also loading conditions are given, and the section size are given, but we are not interested in these parts, so we are only interested in this connection means OC. So can you tell me from the question that what is the diameter of bolt we are using here?
We are using 18 mm dia and the whole dia hole will be 20 mm.
Okay, so how you are getting 20 mm as hole diameter?
One table is there in IS 800 2007 regarding the bolt holes. So less than 22, it is plus 2
Okay,
dia
so
hole.
what type of hole you are taking means considering?
That hole is normal hole, not the oversized or long slotted, not those holes, but the normal hole.
Okay, so we call it
Exact
as
name I don't
clearance
know.
holes. Okay,
What's that?
a clearance holes.
Yes, sir, clearance holes.
Yes, so you remember na?
Yes, sir.
So now see, tell me that now first of all you have to what tell me what first in first step what you have to calculate. First of all, you have calculated diameter of hole.
We
Now
have to
second,
Yes, sir. We have to consider the VDSP nominal share capacity and the bearing capacity of the boards. The number of share planes we have to see and then calculate the bolt value. And
Okay,
then
so can you tell me in member OC? So when you are going to provide bolt in member OC, then your bolt will be in single shear or double shear or triple shear.
here it is single share.
So how you determine that it will be under single shear?
Because in the diagram below there are two ISAs, and here in the OC connection we have only one ISA.
Okay, so please tell me that in member AB, when we are talking about member AB, then member AB will be subjected to single shear or double shear or triple shear
Here it is double shear,
for member
because
AB.
one angle is connected to the gusset plate and then another angle is also connected to the gusset plate, so two shear planes.
Fantastic, Shivam. So please calculate the value for single shear for the member OC shear capacity. Please calculate and report the answer.
Sir, BDSP is the share capacity, design share capacity is 45.83.
45.83. Please see this
No, it
solution.
has not been divided by 1.25.
Okay, okay. Please divide it and check whether 36.67 is coming or not.
Shift. Actually, sir, due to means fast calculation, some mistake
Okay,
is
okay, okay,
occurring. That's
okay,
why
okay.
I'm not able to do so.
Okay. So, have you understand this part of
Yes,
calculation?
sir. Yes, sir. I have
Okay.
understood.
And can you tell me,
There
Shivam,
could
uh, are you doing BTech right now, or you have completed your BTech?
sir, I have completed my BTech. Right now, I was preparing for some competitive exams. Actually,
Okay, okay, okay. So that is why you have opted for this course.
yes, sir.
Uh, Fine. So now, assuming pitch and end distance 50 mm and 35 mm, please calculate the value of kb.
Yes, sir.
take your own time, Shivam. Don't be in hurry.
Yes, sir.
Because in this meeting, we two are only here, so you can solve it by taking your own time.
Yes, sir.
For now, only calculate the value of KB. After that, first tell me value of KB, and after the verification, then move towards calculating the bearing strength.
Sir, it is 0.583.
0.583. Yes, correct. So please proceed further to calculate the bearing strength of the bolt. Do you remember the formula?
Yes, sir.
Or should I tell you?
2.5 kb dt fu upon gamma m
Yes,
b.
yes, correct. So please put all the values.
It is 76.49.
76. No. What is the value of F you have taken?
410.
And value of gamma MB?
Gamma mb 1.25. Let me see.
1.25 kb dt. D you have taken 20 or 18?
D is 18. Oh, sorry, sir. I had taken it as 20.
20. Okay, okay. Please rectify that and then again calculate.
Now I am getting 68.84.
Okay, correct. So now please calculate the strength of angle per pitch length. That is TDN.
Sir, why this is done? Actually, I don't understand the concept behind strength of angle per pitch length.
Means see, you are considering only for the one pitch. Means you are taking that if a single bolt will fail, then this, your section will be fail in a net section. So that is why we are considering here 50 minus 20 only for the single pitch, because we don't know the entire length of the connection here. Okay.
What is 50 and 20?
See, 50, you have already used 50 here while calculating the value of KB. Pitch
Yes,
is 50.
pitch.
Okay, so what is pitch? Pitch is the distance between center to center distance between the two adjacent bolts. Okay, in the
Yes, sir.
direction of the force. So that is equal to 50, and when you are going to deduct 20, means diameter of hole, means if I will draw the diagram, then you can see why it is 1 minute. हाँ One minute. This is your bolt and this is your bolt. So this distance is called pitch. So now you have to deduct half length, means this length, this half length, and this half. So this is half of the diameter, half of the diameter. So complete full diameter of the bolt hole. So that is why we are deducting 50 minus 20. So holes we are considering about the hole diameter, not the bolt diameter, because we are now considering this net means net section rupture we are taking into account. So that is why you have to deduct the single diameter of the hole, means complete hole diameter you have to deduct from the pitch. So that is why you have done here 50 minus 20 into thickness, that is 8.
Sir, why it is in the direction of the loading? Why not perpendicular?
This direction is called gauge, means see, if there is a plate, let us suppose this is a plate and you are going to apply this load. So tendency of failure will be from here also. Okay, so it will, what will happen due to bearing, it will try to means fail the plate from this direction. So that is why we are considering it from here.
Okay, sir.
Because see, here we don't have any type of means bolt diagram, means how we are doing the connection and all that we don't have provided it with. Okay, so that is why we have to assume something.
Sir, why not it is taken as sharing, means sharing of the means the material, sharing of the material.
See, actually, when you will look into the detail, means types of failure, when you will go through the types of failure, then you can see that means from the side, when you are considering from the side failure. So by providing the, we are assuming that by providing the proper end distance or proper edge distance, we are preventing the means shear failure, okay, of the plates. So that is why we are not considering like that, means that is why the IS code books are providing the provisions of having minimum edge distance or end distance. So that is why we are preventing it from the failure from that part.
Okay, sir. So that's why we need to calculate the strength in the parallel, means along the direction of the length, in
In
order
my
to.
next live session, means the various types of failure, I will prepare one slide, means 2 or 3 slides about the failure, means how many types of failure can happen and how many types of failure we can prevent by providing the proper end distance and edge distance. I will make a complete slide for you, and then I will make you explain in a better pictorial form. Okay.
Yes, sir. Okay, sir. Thank you, sir.
Okay, so this is the value of, means we have now we have calculated all these 3 values. So we have to take the, means volt value will be how much less, means minimum of all these 3 value. So this is equal to 36.67 kilonewton, and we have to, means in question you can see here that this plate is subjected to 170 kilonewton of load, okay, and your bolt value is coming out to be 36.67 kilonewton. So we are dividing 170 by 36.67, so it is equal to 4.63, but we cannot provide a 4.63 type of bolt. So we are taking it into means maximum integer, means the nearest maximum integer is 5. So we are reporting as we have to provide 5 bolts for that connection. Now coming to the next question, what is the allowable slenderness ratio of a compression member carrying loads resulting from wind and seismic loads provided the deformation of such a member does not adversely affect the stress in any part of the structure. So see here, means although this is given in, this is a direct question from the IS code book, so I want you to please, if you are having soft copy or hard copy of the IS code book, then please open your code book and please try to find out where it is given, because it is very much necessary to make a habit of opening the code book. I have seen many students that they are not familiar with, means while solving the numericals, if they find themselves to open the code book, they even don't able to find that where those provisions are given. So that is why I will request you to please see, for the time being this is the online session, and for Shivam you are preparing for the examination, so whatever data you will be required, it will be given there only. But the people who are means doing the BTech and taken this course as for the grade, so they have to they will be allowed to take the code book in their examination hall. So it is very much important to be familiar with your code book. If you are not if you are not familiar with your code book, then in examination you will your entire time will lost in searching the coder provisions, that where it is given, and examiner is expecting you to, you should be familiar with your code book. So please I will request to please open the code book and see where this provision is given.
Yes, sir. Uh, Although I have written in my notebook, it is 250, I think.
Okay, 250. Yes, correct answer. And can you say that in which table of IS 800 2007 it is given? Value of this is given?
Table 3 of IS 8000 2007.
Okay, very good, very good. So option D is correct. Table 3 of IS 800 2007, and in video lectures in lecture number 30 it has been discussed. Now coming to the fourth question. The design shear capacity of bolts carrying shear through a packing or filler plate of thickness TPK in excess of 6 mm shall be decreased by a factor beta pkg equal to.
I think, sir, option A.
Yes, option A is correct. So these are the direct values, simple questions. So this has been discussed in, option A is correct, and this has been discussed in lecture number 28. Now coming to the fifth question. Calculate the number of bolts required to connect the outstanding leg of lug angle to outstanding leg of main angle if load on outstanding leg of main member is 120 kilonewton and bolt value is 36 kilonewton. Bolt value is given, means your single your capacity of a single bolt is reported here, and load coming on the outstanding leg of main member is also given here, 120 kilonewton, and they are asking calculate the number of bolts required to connect the outstanding leg of lug angle to outstanding leg of main angle. So they are talking about lug angle and main angle connection. So you have to connect outstanding leg of both main angle and lug angle. So please recall that what is the value of force that is expected to be transmitted from outstanding leg of main member to the lug angle.
Sir, actually, I have to revise it up. I am.
No, you
I
don't
haven't.
need to revise. You have just in above question you have answered this. Only thing you have to means do is to recall. I think in which question? Let me check.
Calculate the number of bolts required to connect the outstanding.
Here you have answered na this 40%.
Yes, sir.
So see, please read again this question.
When yes, sir, I'm getting 40% should be in excess of the force when the outstanding leg of the lug angle is to be connected to the outstanding leg of the main angle.
Okay, so 40% you have reported here, and now in this question, which this, yes, this question. So in outstanding leg of main angle, what they are saying that 120 kilonewton force it is coming. Okay, so how
Yes,
much
sir.
for how much force you have to take into for the lug angle? How much force you will
40%
consider?
more of 120 means 40% more is
Please calculate that.
168 divided by 36 4.6 means 5. I think 5.
4.67. Yes, correct. So see, when this is for you, Shivam, and for all of the students who are preparing for the competitive examination. So see, questions are will be asked simple, but you have to understand the concept behind that. Okay, so if you will not catch the concept, then you can commit mistake in your examination, and even it is also possible that the question which you are knowing will be you will left that question. So here 5. So option C is the correct option. Now coming to the question number 6, which is our last question. So a tension splice is used to connect two tension member plates of size 150 mm by 10 mm. Means you have to do a splicing here. There are two tension member and you have to do a splicing. Can you tell me any example when we go for splicing? Why we go for splicing?
Sir, when the tension member is not one piece, then to connect two tension members, we are using the splicing,
And
doing the splicing.
why we cannot accommodate in a single tension member? Means why there is a size restriction?
Means there must be some means when we are going to the market, we are getting a required means we have a proper length of a tension member, but beyond that we are not able to get. So that's why we need to connect two tension members. In that case, we have to do splicing.
Okay, and why there is a restriction in the size? Means in market, why there are not very long members are coming?
I think, sir, because that means in the market we have a standardized size, and other thing is, sir, I don't know.
Okay, no problem. See, actually, what happens? These are the prefabricated uh, members. Okay, so when you are going to purchase anything from the market, in case of concrete, there is no problem. You can prepare how much length you want. You can prepare at the site. But these things you have to purchase from the market. So that is why when you are purchased from the market, then it should be transported also. So for the ease in the transportation, you have to means manufacturers are limiting the size of the members. Okay, so because if they will be manufacturing very long size, then it cannot be transported from one place to another. So there will be a lots of problem. Okay, in the transportation. So that is why the size of the members are limited. And moreover, you can also expect that for the long size member, how much weight it will have. So taking every practical aspect into picture, we limit the size of the member. Manufacturers limit the size of the member. Okay, so that is why we need to do for we have to go for splicing. Otherwise, if you will make in a single member, then there is no need for splicing. And we prefer also if we can get a single member so that we can accommodate our entire thing, then we can reduce the splicing price, and further our connection will be also good. No need to make joints and all those things, but the thing is we cannot transport those long members. So here it is saying that two plates of size means size of the first plate is 150 mm cross 10 mm, and size of the second plate is 200 mm cross 10 mm. So these are two plates, and these have to be spliced. So the member is subjected to a factored tensile force of 250 kilonewton. Okay, so you have to take into account 250 kilonewton of tensile force. So they are asking that calculate thickness of the splice plate if its strength is 62.58 t, where t is the thickness. So your splice plate means strength of the splice plate is 62.58 t, and you have, members are experiencing 250 kilonewton of load. So what will be the thickness? What will happen? From one member, force will transfer into your connection, and from connection it will be transferred into your splice plate, and from splice plate it will again get transferred into your second part of the connection, and from that second part of connection it will again be transferred into your main plate. So a splice plate should be designed for how much load? This is the
Sir,
means.
we have to divide 250 by 62.58.
Yes, fantastic. So this is our strength of the splice plate, and splice plate should be capable of taking this much load. So for this much load means not capable of, I am trying to say here that this much load your splice plate must take. So minimum thickness will be, minimum thickness of the splice plate which you have to be which you have to keep is to 250 upon 62.58. So that is here P is equal to 250 kilonewton, and strength of the splice plate is 62.58 T kilonewton. So thickness of the splice plate T is equal to 250 upon 62.58, 3.99, that is equal to 4 mm. So minimum thickness must be equal to 4 mm. You cannot keep thickness of means below 4 mm. So this is the C.
Yes.
This is the theoretical value 4 mm. After that means in from the question point of view it is okay. But with that we also have to see that what are the sizes of the, means what are the thickness of the members coming into the market. Means suppose if you are getting 5 mm as your answer, okay, means instead of this 3.99, if you will be getting that 4.99 mm, so you will round it off to 5 mm. But you have to
Yes,
check
sir.
whether 5 mm is available in market or not, because
Yes, sir.
6 mm you will get, but 5 mm you will not get. So that is why you have to check. But each and every thing from the means when code books are not allowed in the examination, so then you will not think that up to this mark means you have been expected to keep those values in the roundup. So you can only think examiner will ask you to be on the safer side, means 4 mm. They are not expecting that if 5 mm will come, then you have to give 6 mm. Like that, in case of weld, you take that what is the minimum value of weld, whether my value is coming lesser than the minimum value of weld. So you have to take, in that case, you have to take minimum value of minimum size of the S means weld size you have to provide. So like that.
Sir, one question has not been means solution has not been provided by Anandrut Lahari sir. That
Please tell
was
me that.
about the HSLG boards when the connection is when there is a centric connection perpendicular to the connection.
Eccentric connection perpendicular to the connection. Okay. So this one you are seeing.
Yes. Yes, sir, I think so. Yes, sir, this one. Uh, he
Okay.
had given the theory, but he was saying that there is means some experiments on some kind of uh, means assumptions are to be considered while.
Shivam, see, actually what happens now means in my live session also, in one of the live session, I don't remember the in which live session, but in one of my live session while discussing the HSFG bolt, no, not HSFG bolt, while discussing the load lying perpendicular to the plane of bolted joint, there I have told you that there are lots of assumptions involved in calculating the h by 7 distance. Okay, so actually what
Yes,
happened that assumptions and the derivation part is not covered in our syllabus, so that is why we don't know actually in depth what is happening there. But if somehow I will find any research paper related to that, means how they are calculating those things, then I will definitely means try to answer your this question. Okay,
because in this book they have taken for HSFG bolts they have taken the center of the connection.
center of the connection.
Means yes, h by 2.
Wait a minute. Let me read it once. Should the depth of neutral axis or
Here h by 7 should be there. H by 7 by mistake I have written 3, it is h by 7.
okay. Should the depth of neutral axis or the axis of rotation should be taken at h by 7 from the bottom edge of bracket or at the center of connection in the case of friction type connection in HSFG bolt instead of bearing type connection. The case is of eccentric connection, okay, when the load lying perpendicular to the plane of bolted joint. Okay, please go through the example of SS Bhavikatti book in the image attached. So for the HSFG bolt, what we do, we make the tightening of the nut so much that uh, those are friction grip bolts. Okay, so we don't expect them to be in bearing or shear. Okay, so for the friction they are designed, so that load will not come, so entire load that is coming will be deal with that part. And the moment, for the moment, so here you are saying that they are taking at this location.
Yes, sir, at the center. At the center they are taking.
Okay,
I have got everything else, but that diagram, the center they are taking. Just I wanted to confirm, is that the case?
okay, so I will have to go through this numerical. Okay,
Yes.
so I will try to discuss in my next live session if it will be understandable to me. Okay,
Yes, sir.
if I will understand, then I will definitely entertain in my next live session this question. And
Yes, sir.
one more thing, Shivam, please tell me. This is the left query. Okay. So from tell me whether these three queries, which means I have left. So these three queries have been entertained by Mr. Anandrup, or whether I need to go through all these questions.
Can you just open the questions?
Okay, sure. Hello, sir. Can we directly calculate the value of LW1 and LW2 in the case of the weld length?
Sir, I'm not able to remember if this was addressed or not.
I have went through this PDF. Means there was some unnecessary calculations. Means without them also LW1 and LW2 can be calculated. Means earlier in the PPT I have gone through this. So
It was about that the average weld length it was taken, I think so.
no, not average weld length. This is not that question. Let me open PPT of this. What is happening? So this is lecture number 25. Okay.
Uh, 26.
Okay, so this is lecture number 25, and timing is means class is at the verge of the completion. So LW1 and LW2. Okay, here it has been calculated, and so what are the things involved in the calculation of LW1 and LW2? So P1 upon TEFU under root gamma MW. So P is 130.7, T is 4.24. Okay, so from where these values are coming?
It was coming from the moments taken in the angle section, means the distribution of the loading.
Design tensile strength of angle is 261.36 coming, okay, which is greater than 200 kilonewton, hence safe. Again, the minimum radius of gyration of the angle, I just say 10.6 mm. Okay.
The angle connection, the centroid of the angle connection, about that, whatever was the load distribution, it was according to that.
Weld will be definitely in calculation of LW1 and LW2. There is means this thing is not coming. Means 261 whatever we are calculating here means taking the minimum value from here, like you can see 654 and 732 or 261.36 will be somewhere. So from here it has been only confirmed that it is not less than 200 kilonewton. But our member is subjected to a load of 200 kilonewton, I guess. So that is why P1 and P2 different means these forces are calculated based on this 200. So let me read one. A tension member 3 meter long carries a factor tensile load of 200 kilonewton. Design a suitable single angle unequal section when connection is made with a 20 mm diameter bolts of grade 4.6 and second fillet weld. Okay, so actually see, design a suitable single angle. They are asking you, means question is asking you to design a suitable single angle unequal section, and the student which has asked is for the welded part. So see, you can calculate directly LW1 and LW2, no issues. But as this is a designing question, so you have to show, means you have to solve that whether your means section is adequate to means whatever section you are taking, so that section is adequate to take the load of 200 kilonewton or not. If your section is not adequate to take the 200 kilonewton of load, then you have to whatever assumptions you have made while assuming the section, you have to change it accordingly.
Yes,
Means
sir.
see here in the very first step only, it has been seen here that a0 means p it is coming 200, means it is given in question, and fy upon gamma m naught, the stress which will come is equal to 250 upon 1.1. So gross required gross area we are getting as 880 mm square, so we have to select the section accordingly whose gross area should be more than 880 mm square. We cannot select any section which whose gross area will be less than 880 mm square. So as this is a design question, so those things must be checked, means for this section all those things should be calculated, then only we can calculate the value of lw1 and lw2. Although in the calculation of lw1 and lw2 there is those things are means those values are not coming into picture, but also we have to show that the section which we have taken is also adequate for the fillet weld. So that is why all those calculations has been done. But if you are concerned only about the calculation, means in examination you have asked that means examiner is not asking you to design the entire thing. If you are a BTech student, means you are not appearing for the competitive examination, then definitely it will come in means maximum chances are there that examiner will ask you to design the connection. So in that case you have to follow the entire step, you cannot escape. But for the competition point of view, or means for short question, if examiner is asking only to calculate you lw1 or lw2, then definitely you can directly calculate, no need to calculate all those things.
Yes, sir.
Okay, so let me check for another question. Shear lag width. So what happened? With reference to clause 6.3.3 of IS 800, how to calculate the shear lag width BS? Okay. Channel 6.
This question you had addressed in,
Yes.
I think, second means
Yes.
previous slides, but you didn't consider the case of
Tubular,
rectangular.
rectangular tube section. Okay. I forget to means what. Actually, I didn't forget. Actually, I was busy in my means seminar preparation. That is why I was not able to give time here. So that is why in this class I have not prepared. But in next class I will try. And what is this gusset plate thickness? Okay. So this mention problem statement for the same.
This was not addressed. It was of, I think, lecture
Actually,
26.
in this question means I'm not able to get what he's trying to ask. Actually, in the numerical question which sir is solving, in that question already entire question has been solved by taking 12 thick gusset plate. So sir, in the current example, thickness of gusset plate is mentioned in problem statement. For the same example, please explain whether 12 thick gusset plate is strong enough to carry all the loads. So I think sir has already designed this thing. So I don't understand that what exactly he is trying to ask. So what is his name? Vimrok. So Vimrok, please, if you will watch this live video, then please make me understand. I am not exactly able to understand that what you want to ask, means what you want to me to do. So please tell me in more detail. other than that, beta factor, huh? So this we are looking, and other than that, why is not bearing stress checked? Sir, in the case of eccentric concern load lying in the plane perpendicular to the plane of bolted joint, why do we not check for bearing stress of the bolt? So, is this question means this question was addressed by Mr. Anand?
No, sir. No, sir.
Okay, okay. So, in my next live session, I will try to make its means solution of this also, if I will understand. Means actually, yes, his concern is right because when load lying to perpendicular to the bolted connection, so in those questions we design for direct shear and for tension and compression coming in the bolts, but we are not concerned about bearing part. Although in my understanding, as I understand, means if there will be bearing, then only shear will happen, na? Means until and unless when bolt will come in contact with the plate, means bolt surface will come into contact with the plate, then only.
Actually, sir, here the lower value is being used na, for shear capacity of bolt and bearing capacity of bolt. The lower value is used as the bolt value.
That is fine, but in the means during lectures also we are not means in the book also it has not been addressed that means for the other examples. First of all, we check na that which value is less, shear value is less or bearing value is less. We check, okay, but here we
But it
don't
has
check.
been taken as shear only. It has been considered as direct load and shear. Do
Yes,
you mean
yes,
that?
yes.
Shear word has been used, not the bearing word has been
So
used.
why bearing is not considered means why we are not checking for the bearing. So I have to means think over that, or I have to discuss it with my another TA, or
Yes, sir.
because in combination of means combined stresses also shear and direct tension we take means we consider, so there will be some provision for this, so that might we are missing. So let me check.
The bolts will undergo the shear as well as the bearing and direct tension. Isn't that
Yes.
the case in ordinary black bolts?
Yes, I am expecting this because you see na, you see yourself means you can think over that means I want to say
The bolt will bear against the holes, and the shear will also come into picture, and direct
shear
tension
will see
will.
my thinking is saying that shear will only come when there will be a bearing, okay, means until and unless a bolt if bolts are not going under bearing, then how shear will come means see uh, actually video I am using for recording this live session, so that is why my video is not visible to you. So sometimes it becomes difficult hard for me to make you understand. So I want to say that when a bolt means surface area of your bolt will coincide with the means hole
There will
diameter
be a
means hole which you have
collision
made.
between the means the bolts will touch with the plate. Then
Yes,
the
yes,
bearing will have.
let me draw a diagram. I'm trying to make a diagram. I want to say here means if you are applying tensile loading, okay, so what will happen, tendency of this plate will be to move this side and tendency of this plate will be to move this side. When bolt will due to this motion, okay, so in order to restrict this motion, what will happen means this
The bolt
contact
will wear
area.
against because
Huh.
it is not a friction type connection. So
So bolt will definitely bolt will bear, and when bolt
yeah,
will bear, then only shear will come, na. Means this
yes sir,
tendency of this bolt is to move this side, and this bolt is to
yes
move
sir,
this side. Then only shear will come here, na. If bearing will not come, then how means automatically shear will come?
yes sir. So I think sir, the minimum value, although it is said that shear is there, but the minimum value, since it is used for both of them, so I think so. That's why they have not used the term.
Okay, it might happen that because we are not providing in these type of connections, we are not providing bolts in double shear. So if bolts are not in double shear, then in general it happens that for single shear value of shear will be less than the bearing value. So that is
Yeah.
why they might have taken, but I have to look it once. I will discuss it with my friends, means another TA and my friends. I will discuss.
Yes, sir.
Okay.
And that question also, that HSFG pose eccentric connection, sir.
Yes,
Please
yes.
to consider.
H by 7, that na, that part.
Yes, sir. H by 2 and H by 7, which one to be used?
H by 2. Oh, okay, okay. In that
Means
case, you are
set.
saying that H by 2 they have taken for HSFG bolt. Okay, okay.
Yes.
Yes, sure. Okay.